Hi, I'm Drew Massey, and I'm a chief engineer working in physical AI at Booz Allen. Traditional aerial 3D reconstruction workflows require significant processing time and often focus only on the purely visual elements of a 3D model. They lack the physical characteristics of the world that can inform advanced simulations and digital twins. To address these challenges, Booz Allen, in collaboration with NVIDIA, has invested in developing a workflow which rapidly and automatically extracts features from video and image data to generate high-fidelity, visually and physically accurate 3D reconstructions from UAV data. Our aerial reconstruction workflow consists of 7 key steps. We start with data capture. The techniques that we'll discuss later in the workflow depend on certain aspects of this stage to ensure the highest output quality. To support this, we've developed best practices in oblique capture to ensure that we have adequate and overlapping coverage of an area of interest. This data capture can either be video or image data taken from an electro-optical camera sensor. Next, we feed this captured data into our feature matching workflow, which utilizes structure from motion techniques to produce a sparse and dense point cloud output of overlapping points from the images. From here, we utilize the feature matching outputs to generate Gaussian splats and meshing. For high-quality Gaussian splats, we leverage the latest NVIDIA FVDB workflow, along with a 3D Gaussian splatting algorithm to generate high-quality representations of the environment. For meshing, we've developed modules leveraging Poisson reconstruction and truncated sine distance field functions to convert the set of points into a mesh. These algorithms build out the 3D geometry of the model, which provides a surface to the object. This mesh can then be used to provide collision for an autonomous asset in simulation. We then perform 3D segmentation of this output using semantic segmentation techniques to provide an additional layer of metadata that we use to tie physical properties to the visual data. For example, this segmentation model can be used to extract dirt or road material from the data as an image mask. This can then be applied to a roughness texture to the material of the 3D mesh, which will then in turn affect the friction of the material as a ground vehicle drives across it. Finally, we integrate the 3D and segmentation data to build 3D content in our simulation software that will inform AI and autonomy training. This final reconstruction can be used to train, test, and evaluate perception models for an autonomous system, such as how the tracking algorithm is being affected by the reflection of a metal barrier, or how the actuation model of a ground robot is affected by loose soil and difficult terrain. Booz Allen understands the importance of creating simulations and digital twins that are both visually and physically accurate. Our automated workflow speeds your 3D reconstruction process and provides an additional layer of metadata and physics. What once took a month or more can now be completed in under an hour. By leveraging our workflow, clients will save significant costs in labor and achieve results faster.